Welcome to our lesson in physics, linear motion, but this is SPSS. This is student problem solving session. Okay, so we are looking at how we apply the knowledge we have learned in various scenarios. Okay, a car decelerates uniformly from a velocity of 10 to rest in 2 seconds. Okay, so this car is slowing down, it is decelerating, slowing down, okay, until it stops, and that happens in 2 seconds. It takes 2 seconds to reverse with uniform acceleration to its original starting points. You see, it takes 2 seconds to accelerate. It is doing the reverse of deceleration. It has to accelerate back to original position. Okay, so there are few things that we have to understand. Maybe this car starts at some velocity. It has 10 meters per second. That is its initial velocity u. And then it is slowing down. So maybe it is reading 8 meters per second. It is reading maybe 6 meters per second. That is what we mean by deceleration. A higher velocity dying out within a given time. Deceleration. But when we have a velocity building up from maybe 5 to 10 meters per second to 15 meters per second to 20, that is what we call acceleration. So let us look at a few questions. Determine displacement. So here we are testing your ability to know that displacement is a straight line from starting point to the destination, to the final point. So in our case, what can we say? It started at point maybe X, went, and then came back. So if you join starting point to stopping point, it is the same place. So by reasoning, it is actually 0. So that is A. Okay. Then B, we are told average velocity. B is average velocity. Okay. Now I want you to get it very clearly. Velocity is a vector quantity. So the velocity we attach for the portion of the motion decelerating, the sign we attach for the portion of motion deceleration, if we assign that as negative, then coming back acceleration will be positive and vice versa. Get me right? Velocity is a vector quantity. So it must have a sign to show us away from a point and back to a point. And there are only 2 signs, positive and negative. Therefore, I can say, maybe I use A here. A displacement is equal to 0. Okay? Okay? So there is no length that exists from starting point to end point. Starting point to end point distance is 0. Okay? So we can write here from starting point to stopping is equal to 0. That is the reason. Now, can we write B here? Average velocity. So let us say this is starting point, start. What I'm saying, if it is going that way, U is equal to 10. Here, V is equal to 0. So let me call this stop. If we take that direction as 10, positive 10, then what am I trying to say here? This way will be minus 10. Get it? If I take reducing in velocity as negative, then coming this way will be positive. Remember, this positive and negative are the ones which take care of going and reverse. Okay? It's like left and right. So when I want average velocity here for this motion, I'll say average velocity is equal to, these are two portions of journey. So I'll say 10 plus negative 10 divided by 2, which is equal to 0. Okay? That is what I would put. That is what I would put for average velocity. The sign tells you there was reverse in straight line motion. Okay? Right. Can we focus down a bit? Yes. Now, let us look at C. C is asking distance traveled. What is the distance traveled? Distance traveled, two parts of motion. One, distance will equal to average velocity, speed 1, average speed times time. Okay? The average speed is 10 plus 0 over 2, then times 2. So this is part of the motion of deceleration. Okay? Then plus another average speed times time. So plus 0 plus 10 over 2, again times 2. Reverse. So why do I use average velocity? Because this vehicle started at 10 and then stopped. So U plus V. That part of motion entails an average speed. Okay? Which gives me now, if we do this, it gives me this, and this is 10 and that one is 20 meters. I want us to look at this graphically. What would it mean? How would I handle it graphically? Let me focus a bit here. So if I was to draw a diagram, it would be like that. So this is 10, this would be negative 10, this would be 2, and this would be 4. This is velocity in meter per second, and this is about time in second. So I can also get using the area. Remember, when you multiply velocity times time, you get area. Okay, you get area. This would be a half. So we are talking of this area. That. So you can see it will be a half area is equal to a half base 2 times 10 plus a half base 2 times 10. Now distance, I've used this and that, the tens, but I've not put there 10 because I'm talking of distance. It is a vector, it is a scalar quantity. So let us see, when you have this and this, you still get the same 20. This is graphically, this is by normal calculation. Okay? That should make sense. And finally, if I talk of average speed, D. If I talk of average speed, average speed, okay? Average speed is total distance divided by total time. Total distance divided by total time, which gives me 5 meters per second. Total distance, this, either using just normal calculation or graphically, 20. Total time, you can see it is from 0 to 4. So you get that is the average speed. Understand each concept, and especially here, because the simple mistake you can make is by using distance is speed times time, and then you say the speed was 10 times time to 20, then you get also there 20. It cannot work that way. Reason being, there was this change, there were these velocities, but if he asks you distance, when it is moving at uniform speed, then you use that uniform speed. Because if it was uniform speed 10, it would be 10 plus 10 divided by 2, which is the same as 10. Get it right. If it was moving at a uniform velocity of 10, uniform, that figure 10 still stands for speed. But the fact that he mentioned velocity, it means there was a particular direction. So what would you do here? It would be just 10 times 2 if the time taken was 2. Look at it in another angle. It would be 10 plus 10 divided by 2, which still remains 10. Do you understand now? If he said uniform speed, I would not use 10 plus something over 2. No, it would be a waste of time, but you can do it. So this, very important. It makes the difference. So as I conclude, displacement is from starting point to the end point. Then you measure the length or use Pythagoras or SOHCAHTOA. Those are the tools. Average velocity. He is testing your ability to see if you have understood direction in terms of sign. If going left is negative, then going right is positive, and vice versa. That was the test in B. In C, distance traveled. Distance is speed times time, but you get average speed. That was the trick. Okay? You can do it using the formula or velocity time graph. I want to tell you that I have no space to write, but you can always have a note somewhere, okay? The graph work is very important to support your theory. Very important. In graph work, the questions that are tested are: 1. Do you understand the meaning of vertical quantity, whatever goes on the y-axis, divided by what goes on x-axis? So I call it vertical quantity divided by horizontal quantity. In our initial stages of learning linear equation, we call that gradient. Then, when you take the vertical quantity multiplied by horizontal quantity, is basically the area. But when you use units for that multiplication, it will give birth to a unit whose quantity can be explained. E.g., vertical quantity is meter per second, m/s, multiplied by horizontal quantity whose unit is s. So we have m/s times s. So s and s cancel. Which unit remains? Meter. So in the course of getting area diagrammatically, that area represents a quantity in physics. It's not just area. Area is a backup. That what have I done? I've multiplied vertical quantity by horizontal quantity. Then number 3, intercepts. So vertical quantity over horizontal quantity, normally gradient. What is the meaning of that? 2, vertical quantity times horizontal quantity is the area, but what does it stand for in physics? 3, what is the meaning of intercepts? Once you have those ones in graph work, you are done. Okay? Keep on subscribing. You get something small. Always have a note to write. Thank you very much. Bye-bye.